Hey guys, this video is about mixtures. Mixtures are a very important section in chemistry. Mixtures is something that you need to be able to identify and differentiate between them if you're given them. So, for example, let's look at ink. What makes up ink? What is in ink? Like black ink, blue ink, purple ink. What makes it up? Well, essentially there's alcohol and there's the different colors, which we call pigment, and they're mixed up to form that color ink. Okay? Now here's an important question. Is ink a pure substance or is it a mixture? Well, if you're putting things together, ink has got to be a mixture. All right? So mixture is what ink is. Now mixture, what is it? It's a physical blend of two or more kinds of matter, each which retains its own identity and properties. All right. Now, ink can be separated, believe it or not. Even though it's a liquid, there's a way to separate it. It's called chromatography. So, in ink, those pigments are not permanently attached. They're not bonded forever. They're just in there mixed up. Kind of like oil and water. You shake it up, you mix it up really good. Okay, they're mixed up together. They're not permanently attached. Now, there's a very important term called phase. Okay, phase is used to describe any part of a sample with uniform composition and properties. Okay, they are the visible ingredients or parts to the mixtures. All right, so let's take a look at the two types of mixtures. The first one is a heterogeneous mixture. It's a mixture in which the composition is not uniform throughout. Okay, it consists of two or more phases. Some examples of heterogeneous mixtures include the following. Pizza, you have your cheese, your sauce, your dough. Apples and oranges, basic mixture. You can get the apples and the oranges. You can clearly see the differentiation between the two, and you can separate them. Cherry jello and fruit. Okay, you see fruit floating in the jello. Perfect. That's a heterogeneous mixture. Oil and vinegar, that's unshaken. You have the two layers. You have the oil, which is less dense, floating on top, and the vinegar at the bottom. Sand and salt, and there's a lab that we usually do to separate these two. Salt dissolves in water, whereas sand does not. Then if you had a mixture of, say, gold, silver, and platinum, you can clearly see the difference between the three of them, and you can simply separate them, no problem. Okay, so heterogeneous mixtures are the ones you can readily see the distinct phases in that mixture. Okay, the next one is homogeneous mixtures. Now this is one we're going to be working with most of the time in chemistry. A homogeneous mixture is a mixture in which the composition is uniform throughout. Now, we call heterogeneous mixtures solutions. So if you're working with the solution, it's simply a homogeneous mixture. Now, a homogeneous mixture, say, like let's take some salt, sprinkle some salt in some pure water. Now we have pure salt water. Okay, it forms one single phase. You cannot see the salt dissolve in the water. So that's the important aspect of a homogeneous mixture. You only see the water phase. So it only has one phase. Now, some examples of homogeneous mixtures: apple juice, air, and remember air is a mixture of oxygen and nitrogen, salt water, which is salt dissolved in water, food coloring, vinegar. Vinegar is actually acetic acid dissolved in water. Vinegar is 7% acetic acid. Vinegar is a very dilute version of acetic acid. And also shaken olive oil and vinegar, or even oil and vinegar, or water and vinegar. You shake it up, it mixes up, it's one phase. But over time, the oil and the vinegar separate, and you see two different phases. Okay, but still, once it's shaken, it is one phase. Now, separating mixtures. There's two important techniques you need to be familiar with. The first one is filtration. Very simple. It's a process that separates a solid from liquid in a heterogeneous mixture. And the other one is distillation. A liquid is boiled to produce a vapor that is condensed into a liquid. This is more or less usually done with a homogeneous mixture, however, not necessarily true. Okay, but you can say separate two liquids. Okay, if you look at their physical properties, their boiling points. Okay, alcohol has a lower boiling point than water, so you can distill the alcohol out of the water. Okay, creating a distillate, which is the alcohol being produced out of the water. You're separating a homogeneous mixture. Okay, so and there's also one called chromatography, which your book doesn't get into, but it's very important. It's called paper chromatography, um, and that is used to separate mixtures like ink. Okay, if you take black ink, put it on chromatography paper, okay, set it up, put the chromatography paper into a liquid. The liquid is going to be pulled up into the paper, causing the black ink to dissolve and go up the paper and separate into different color bands. And you can see the distinct colors in there, and that's chromatography. That's a really cool one. Okay, but here's a look at what the distillation apparatus looks like. You have your round bottom flask with a thermometer capped at the top so nothing can escape. So as you heat up the liquid with the Bunsen burner, the vapors go up and go down this tube, okay? And over here is a water jacket which cools this tube, causing the vapor to condense down into a liquid, into the distillate, which is in the receiving flask. So this is the distillate, okay? This is a lighter color than this color here. So you're separating two liquids. Distilled water is made the same way. Distilled water has many fewer impurities and metals in it than it does tap water. Okay, so it's a water that has less in it distilled. So you take the water, tap water, heat it up, and all the metals stay behind that are found in the water. And the water itself just goes down here, cools off into the water vapor into the retrieving flask. Okay, and that's it.